Hi, Integrated Science. This is Miss Satterley. I'm going to go over the kinetic theory notes. So kinetic theory has to do with kinetic energy. Kinetic energy is the energy of an object due to motion. The faster the object moves, the greater the kinetic energy. So if you look at the picture here, we have two types of energy, kinetic and potential. Kinetic is energy of motion. So going up the hill, energy is taken in. At the top, there is potential energy, which is stored energy, and then going down the hill, energy is released. Kinetic theory of matter. This states that all particles of matter are in constant motion, and it's developed to explain the behavior of gases. It does work with both solids and liquids, but it is more for gases. So solids actually vibrate in a particular spot. Liquids also move, but gases really move all over the place. This helps explain the behavior of gases. So kinetic energy is transferred during collision of particles. So when gas particles run into each other, they're going to transfer the kinetic energy that they have into the other particles. Particles in a gas are never at rest. So during a collision, one atom loses energy and causes it to slow down, while another atom is going to gain energy and causing it to speed up. So this is how motion of gases works. There are forces of attraction among particles and matter. If particles are apart and moving faster, the attractions are too weak to have any effect. This is why gas itself is able to spread out into an entire room, because the particles are too far apart to actually be held together. Now, liquids and solids are different because they're closer together, so the attraction between particles is going to keep them together. So, kinetic theory of gases states that a constant motion of particles in a gas allows a gas to fill a container of any shape or size. So I just mentioned that. There are three main points. Gas particles are in constant motion. Motion of one particle is unaffected by another unless a collision occurs. And forces of attraction among particles in a gas can be ignored under ordinary conditions. Kinetic theory of matter can also be used to explain behavior of liquids. Particles in a liquid are more closely packed than particles in a gas. Therefore, attractions between particles do affect the movement of particles. It's kind of like a tug of war between constant motion of particles and the attraction among them. A liquid takes the shape of its container because particles in a liquid can flow to new locations. This has to do with its indefinite shape. Volume of a liquid is constant because forces of attraction keep the particles close together. So instead of filling up an entire room, it's only going to cover the area that the volume will fill up. Now we're going to explain the behavior of solids. Solids have a definite volume and shape because particles in a solid vibrate around fixed locations. This is because there is a strong attraction between particles, which restricts its motion. This is the last slide for today. This is applying the kinetic theory of matter to the three different states of matter. What you need to do today is you need to watch this video and make sure you have your notes finished. If you have any questions, please let me know. Bye.